Hi everyone, Ramesh here, back again with another video. In this video, I'm going to show you how to create a Spring Boot CRUD REST API application using IntelliJ IDEA. Well, I have already published many videos on how to create Spring Boot CRUD REST APIs using Eclipse STS ID. Okay, and many of you guys suggested me to use IntelliJ IDEA to build Spring Boot CRUD REST APIs. Well, in this video, we're gonna use IntelliJ IDEA to create a Spring Boot CRUD REST APIs line by line coding. And we're gonna use MySQL database and we're gonna use Postman REST client to test all the Spring Boot REST APIs. And we're gonna use Spring Data JPA, which internally uses Hibernate, to build a repository layer or a DAO layer. Okay, great. Without further ado, let's go ahead and let's create a Spring Boot project using Spring Initializer, and let's import Spring Boot project in IntelliJ IDEA, and let's go ahead and let's build Spring Boot CRUD REST endpoints line by line coding in IntelliJ IDEA. Alright, great. In order to create a Spring Boot application, we are going to use Spring Initializer. Well, let's head over to your favorite browser. I am in a Chrome browser, and in a new tab just type start.spring.io. This will bring up Spring Initializer website. Okay, so Spring Initializer is basically a website which we can use to create Spring Boot application. Okay, well, here we have a project types like Maven project and Gradle project. Let's keep Maven project selected as it is, and language Java, Spring Boot version 2.5.5. So don't choose snapshot or other releases, just keep default selected one, that is 2.5.5. so this is the latest and stable version of Spring Boot. Now go ahead and enter the project metadata over here. So let's give group ID as net.javaguides and artifact ID as Spring Boot backend, and description something like demo project for Spring Boot REST APIs. Alright, and package name net.javaguide.springboot. Perfect. Packaging keep jar and Java version 11. You can choose 17 or 8 as per your JDK installation on your machine. Okay, so go ahead and click on add dependencies over here, and here we are going to choose the dependencies. Let's go ahead and let's choose Spring Web dependency. Well, we are going to build a REST APIs, guys. That's why we are going to choose Spring Web dependency. Well, Spring Web dependency we use to build REST APIs as well as Spring MVC applications. And Spring Web dependency internally provides Apache Tomcat as a default embedded container. So go ahead and pick up this dependency. Apart from that, we are going to use Spring Data JPA. Well, in order to talk with the database, we are going to use Spring Data JPA. And Spring Data JPA internally uses Hibernate as a default JPA provider. Okay, so Spring Data JPA is very useful module, guys. It reduces a lot of boilerplate code that is required to develop the DAO layer or a repository layer. So we are going to use Spring Data JPA. So apart from that, we are going to use a MySQL database at a backend. So in order to connect MySQL database from our Spring Boot application, we are going to use MySQL JDBC driver. Alright, so apart from that, we need a Lombok dependency to reduce a boilerplate code. Okay, so these are the dependencies that are enough to create our Spring Boot application and exposing CRUD REST APIs. Okay, so next you can explore this project by using explore option over here. For example, you can see what are the dependencies you have added to Spring Boot application. You can explore the project structure. Okay, so just go ahead and close it and click on generate to generate this project as a zip file on your file system. So go ahead and click on generate. So look at here, this Spring Boot application is downloaded as a zip file. Now let's go ahead and open in a folder and just extract this zip file. Okay, now open IntelliJ IDEA and import this Spring Boot application in IntelliJ IDEA. So I have opened IntelliJ IDEA, and here you can see open button. So you can click on open button to open existing project. So go ahead and click on open and go to the directory where your project is downloaded. So my project is downloaded under downloads folder. So I go to downloads folder and just select Spring Boot backend project and open in IntelliJ IDEA. Okay, so this will take a couple of seconds to import Spring Boot project properly in IntelliJ IDEA. Alright, our Spring Boot application is properly imported in IntelliJ IDEA. Next, what we're going to do is we're going to create project structure for our Spring Boot application. Well, just expand our project, go to root package, right click on it, new, and then choose package. Let's give package name as model. So within a model package we keep all our JPA entities. So let's go and let's create one more package, right click, new, and package, and let's give package name as controller. So within a controller package we keep all our Spring MVC controller. So let's go and let's create one more package and let's call it as a repository. So within a repository we keep all our Spring Data JPA repositories. So right click on root package, new, and then choose package, and let's create one more package, something like exception. Alright, once we have created a packaging structure for our Spring Boot application, next we're going to configure MySQL database in our Spring Boot application. Well, go to a resource folder. Within resource folder you can see application.properties file. So all the application level configuration we keep within a application.properties file. So before configuring MySQL database in Spring Boot application, first we need to create a database in MySQL server. So let me go to the terminal over here and let me connect to MySQL server by using terminal or command prompt. If you are using MySQL Workbench, then you can also create a database using MySQL Workbench. Okay, so I have connected to MySQL cell, and here I am going to create a database. Just execute the query, create database, and let's say name of the database is EMS, that is Employee Management System. Hit enter, and there we go. We have created database. We have created EMS database. If you want to see the database, just type the command show databases, and you can able to see here EMS database is listed in a MySQL database server. Alright, now let's get back to IntelliJ IDEA, and here we're going to configure MySQL database configuration in Spring Boot application. So within application.properties file, just type these properties: spring.datasource.url and JDBC, MySQL, localhost 3306, the port of MySQL server, EMS is the database name just we have created, and we have disabled the SSL, and username root, and this is a password for my MySQL installation. So make sure that you have replaced this username and password as per your MySQL installation. Okay, I have seen that many of you guys don't replace this username and password as per your MySQL installation, and you cannot able to connect your Spring Boot application to MySQL database. So make sure that you will replace MySQL username and password as per your MySQL installation in your machine. And then we need to specify the Hibernate dilate for MySQL database. Okay, so Hibernate internally uses this dilate to create SQL and execute SQL as per the database. So in our case we are using MySQL database, and here we are using update value for DDL auto property because this property is very useful while development, guys. So this property will update the existing tables if tables are not existing database, and if tables are not existing database, then it will create a fresh tables. Okay, so it won't delete the existing tables. Let's say if we add a new column to the existing table, then it will simply alter the table, it won't delete the table. Okay, so very useful property. But if you are deploying your application on production, then make sure that you use the property value as validate or create. Okay, create or drop. For development, I am going to use update. Okay, so these properties you can copy from my GitHub repo. Okay, I will host source code of this project after completing this course, and you can get this code from the GitHub repo, or I will give a link in a video description for the same, and you can also copy this code from my blog post. Okay, I will provide a link in a video description. Alright guys, now we have configured MySQL database in Spring Boot application. Let's run our Spring Boot application. Let's see whether our Spring Boot application is able to connect to MySQL database or not. Okay, go to Spring Boot main entry point class, and here we can run this class as a Java main class. Okay, because this class has a main method, so we can run this application as a standalone. And if you can see in a console, Spring Boot application is up and running in an embedded Tomcat server on port 800, and there is no error in a console. It means that our Spring Boot application is successfully connected to MySQL database. Let's go to model package, right click on model package new, and then choose Java class, and let's give class name as employee. Hit enter, and let's define few instance variables. Private long id, so this will become a primary key for employees table, and then private string first name of the employee. Similarly, let's have a last name of the employee. Let's create one more field, something like email ID. Okay, great. Let's use Lombok annotation to reduce a boilerplate code. So I'm going to use add getter Lombok annotation to create a getter methods for these private fields, and I'm going to use add setter Lombok annotation to create a setter methods for these private fields, and we're going to use no argument constructor, and also we're going to use all argument constructor. Okay, great. So instead of these two dependencies, you can also use add data Lombok annotation. For example, add data Lombok annotation. But add data Lombok annotation internally provides so many things, like it internally generates toString method, hashcode method, equals method. Okay, so we don't want all those methods, so we're gonna simply use add getter and add setter methods here, setter annotations over here. Okay, great. Now I'm gonna use JPA annotation to make this class as a JPA entity. Let's add entity JPA annotation to make this class as a JPA entity, and I'm gonna use add table annotation to provide table data details over here. So let's give table name as employees. You can also specify schema and other details. Okay, to keep it simple, we just give table name to this class, and apart from that, we're gonna use @id JPA annotation to make this id as a primary key, and also we're gonna specify @generated value annotation here, because we need to provide primary key generation strategy, right? So let's give identity as a primary key generation strategy, and here we're gonna use @column annotation to map a column name or to create a column name for this field. Let's give column name something like first underscore name, and you can also specify null label here. If you specify null label equal to false, then this column becomes not null. Okay, so go ahead and remove this. Similarly, let's give column name for last name as well. Name equals to last underscore name. Okay, and here we're going to specify name for email underscore id. Okay, perfect. If you don't specify @column annotation, then JPA internally by default pick up this property name as a column name. Okay, if you don't specify at column annotation like this, then JPA is not enough to give a column name as name of this field. Okay, so we want column name as email_id, hence we need to specify this annotation. Now what we'll do, we'll run our Spring Boot application and we'll see whether this employees table will get created in a database or not. Let me go to Spring main entry point class and let me run this Spring Boot project. And our Spring Boot application is up and running in an embedded Tomcat server in port 8080. Now let's head over to terminal. If you have MySQL Workbench, then you can go ahead and you can just open EMS database. Okay, I say use EMS here. Database changed, and I will say show tables, and there we go. The employees table is successfully created in EMS database. It means that our JPA entity created successfully. Okay, next what we're going to do is we're going to create Spring Data JPA repository. Go to repository package, right click, new, and then choose Java class and choose interface here, and just give interface name as employee repository. Hit enter, and this repository should extend JPA repository. And JPA repository interface expect two parameters. First is type of the JPA entity, second type of the primary key. So we have given type as long to the primary key, hence we have specified employee as a long as a type here as a second parameter, and this is the employee JPA entity type. Okay, and here we don't have to add a repository annotation here because Spring Data JPA internally take care of adding at repository annotation to JPA repository implementation class. Okay, great. Now we have created employee repository which extends JPA repository. Now this employee repository will get all the CRUD database methods. Okay, all CRUD database methods to interact with the database. Alright, once we create employee repository, next we're going to create one custom exception, that is resource not found exception. So whenever a record not exist in database table, then our application should throw the exception. That exception will be again sent back to the client, right? So for that, go to the exception package, right click on it, new, and choose Java class, and let's give class name as resource not found exception, and hit enter. And this exception should extend runtime exception. Okay, and go ahead and create one constructor over here, public resource not found, and here we're gonna pass message, and this constructor takes a parameter as message. Okay, great. Now what we're gonna do is we're gonna annotate this exception with one very important annotation, that is at response status annotation. So we can also annotate this, we can also use this annotation in REST API, but instead of repeating this annotation in each and every REST API which throws this exception, we can simply add this annotation in a common place, okay, in this custom exception itself. We no need to repeat this annotation in all the REST APIs which throw this exception. Okay, so whenever a REST API throw this exception, the REST API should return this exception message to the client, right, with status code not found. For that, we're going to define a value here. Status value is not found, right? HTTP status dot not found. Okay, great. Well, go to controller package, right click on controller package, new, and then choose Java class and let's give class name as employee controller. Let's annotate this class with @REST_controller annotation, and @REST_controller annotation internally annotated with @controller and @response_body annotation. So once we add this annotation, that is a REST controller annotation, to this class becomes Spring MVC REST controller and capable to handle the HTTP requests. And all the REST API that we are going to build, that we will define within this class. Okay, so now go ahead and auto-wire employee repository, private employee repository and employee repository. Great. Now let's create a method public with return a list of employees. So give list of type employee. Let's give method name as get all employees. Okay, and we don't have to pass any argument to this method, so this method simply returns list of employees. So we need to fetch a list of employees from the database. For that we're going to use employee repository dot find all method. So look at here, find all method returns a list of objects, in our case list of employees. Alright, now let's annotate this method with @get mapping annotation. Okay, now what we're going to do is we're going to define a common base URL for this REST APIs. For that we're going to use @request mapping annotation here, and here give a base URL for all these REST APIs, that is API/v1/employees. Okay, great. Now this API will return a list of employees to the client. Okay, great. Now before testing this REST API, what we're going to do is we're going to insert few records to the database, so that whenever we test this REST API will return those records from the database. So go to main entry point class, and here just implement command line runner interface. This will provide a run method, and this run method basically executes whenever our Spring Boot application starts first time. Okay, before writing any code within a run method, first we're gonna auto-wire employee repository. Perfect. Now within a main method, create object of employee and just set value to the employee dot set first name, let's say Ramesh, employee dot set last name Fadhari, and employee dot set email ID ramesh@gmail.com, and we're gonna call employee repository dot save method to save this employee object to the database. Similarly, let me copy this code and let me insert one more record. Copy this, paste it here, and just rename the object employee 1. Okay, and just change the values. Let's say John, Sina, and email as sina@gmail.com. Okay, great. Now what we're going to do is we're going to run our Spring Boot application and we'll test get all employees REST API. So go to main entry point class again, and from here we can run our Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Let's head over to Postman client. So I'm in a Postman client. I will create a new request over here and choose HTTP GET method and type HTTP localhost :8080/API/v1/employees, and go ahead and click on send button, and there we go. REST API return a list of employee objects. Okay, we have successfully got a response of the REST API as a list of employees. It means that we have created get all employees REST API successfully. We are going to build create employee REST API. So create employee REST API basically handle HTTP post request, and it will get a employee JSON object from the request, and it will convert it into employee Java object, and it will save employee Java object in a database, and it will return the employee saved object to the client. Alright, go to employee controller, and here let me write the comment build create employee REST API. Okay, and just create a method public, and the return type of the method is employee, and give method name something like create employee, and just pass method argument as employee object. Okay, and this method returns the saved employee object. Okay, just call employee repository and call save method. So save method takes entity object, so just pass employee object, and that's it. So save method basically returns the saved object. In our case it's employee object. Okay, and let's annotate this method with add post mapping annotation to handle HTTP post request, and we no need to give a URL something like /employees over here. Okay, because the employees already added in a base URL. Okay, let me remove this. Perfect. And here you can see method argument employee. So we have an annotation in Spring that is at request body annotation. So this annotation will basically convert a JSON into Java object. Okay, great. Now let me save the file, and let me start the Spring Boot application, and then we'll test this REST API using Postman REST client. Alright, our Spring Boot application is up and running. Let's head over to Postman client and create a new request, and make sure that you choose HTTP post here, and just type here HTTP localhost :/API/v1/employees. Okay, and go to body and go to raw, and here choose content type as a JSON because we are passing JSON in a request body, and here we need to prepare the JSON. Well, if you can see the employee object that we have passed to this create employee method, it has first name, last name, and email ID. So we need to prepare a JSON such a way that we need to pass key as a first name, last name, and email ID. So key should be same as first name, last name, and email ID. Alright, so go ahead and in a body section just add first name, okay, and value as let's say Ramesh, and let's say last name. So we have a record already with the name Ramesh, so let me add different record here, something like Umesh. Okay, and give last name as a Fartare, and email ID, let's give something like fartare@gmail.com. okay, and go ahead and click on send button, and there we go. We have already 2 records in a database table. Now third record is inserted, and REST API returned third record with ID 3. Okay, it means that our create employee REST API is working as expected. Let's go ahead and let's build get employee by ID REST API. So head over to employee controller, and within the employee controller we are going to write the get employee by ID REST API. So let me write the comment over here, build get employee by ID REST API. Well, let's go ahead and let's create a method public, and the return type of the method, let's go ahead and let's use response entity. So response entity is very useful class that we can use to construct the response of the REST API. So go ahead and choose response entity, and this is a generic class, so we need to pass the type. In our case, we need to pass employee. Let's give method name as get employee by ID. Okay, and we need to pass the method argument for this method. Let's say ID of type long. Now we need to fetch employee object from the database. For that, what we're going to do is we're going to use employee repository to get the employee object from the database. So let me first declare employee object over here, and let's use employee repository, and it provides a method called find by ID. So find by ID method takes ID of type long, and it returns the optional class of type employee. So go ahead and choose this method and just pass ID. Well, find by ID method returns optional class, and optional class provides the method or else throw method. Well, if record is not exist with a given ID, then our REST API should throw the exception, and our REST API should return a error response to the client, right? In order to handle this use case, what we're going to do is we're going to use or else throw method to create a custom exception and throw the custom exception. Okay, so go ahead and choose or else throw method, and if you can see here, or else throw method takes supplier as a argument. Supplier is nothing but a functional interface, and we need to provide a lambda expression implementation for this interface. So go ahead and choose this method, and we are going to write a lambda expression, and here is the syntax: new, and then create object of resource not found exception and throw this object. Okay, let me break this sentence here, and we need to pass a custom error message, something like employee not exist with ID, and just pass the ID over here. Okay, great, that's it. Now we got an employee object from the database. Now this method should return response entity, and just call OK method here. So we're gonna call OK method because it internally provides 200 status code. We don't have to manually specify 200 status code as a response of this response entity class. We simply call OK method, and we need to pass a body. In our case, we need to pass an employee object in a body. That's it, guys. Now we have created a method which returns an employee object. Let's make this method as a REST API by using Spring provided annotations. So let's go ahead and let's add get mapping annotation at the top of this method. Okay, and we need to pass ID. So within a curly braces, provide a ID, and we need to bind a value of this ID to the method argument. For that, we're going to use add path variable annotation. That's it. Pretty simple, isn't it? Now save this class and go ahead and run Spring Boot application again. Well, our Spring Boot application is up and running. Let's head over to Postman client and let's test this REST API. So in a Postman client, create a new request to test this REST API, and make sure that you choose HTTP GET method over here, and just enter the URL http localhost 8080 API/v1/employees, and just pass the ID. Here we are passing ID 1. We need to get an employee with ID 1, right? That's the reason I'm passing 1 here. And go ahead and click on send button, and you can able to see here REST API return the response with the ID 1. Okay, we got a response as an employee object with ID 1. If you want to retrieve employee with ID 2, then go ahead and pass ID 2 over here, and there we go. REST API return an employee object with ID 2. If you want to get an employee with ID 3, you can just pass ID 3 and hit send button, and there we go. REST API return an employee with ID 3. It means that get employee by ID REST API working as expected. Let's go ahead and let's build update employee REST API. So head over to employee controller again, and within employee controller, we're gonna write update employee REST API. So let me quickly write the comment over here, build update employee REST API. Okay, great. Now quickly write the method public, and the response type we are going to choose here response entity. Well, response entity is very useful class to construct the response object, so go ahead and choose response entity. Response entity is a generic class. We need to provide a type. Let's go and let's provide a type as an employee, and go ahead and give method name as update employee. Alright, and we need to pass first argument as ID and second argument as the type of the employee object. Update details, let's say employee details. Okay, so employee details, basically this object we are getting from the client. So client call this REST API, that is update employee REST API, and it sent updated employee information in the request, right? And that information we are going to bind to this employee object. Alright, great. Now what we're going to do is we're going to get the employee object from the database, and we need to update the employee object, and we need to again save that employee object to the database. For that, let's go ahead and let's first fetch employee object from the database. So in order to do that, let me declare an object here, employee, and let's say update employee, and we're going to use employee repository to get an employee object from the database. So employee repository provides a method that is find by ID method, find by ID, and find by ID method takes ID as a method argument, and it returns optional class of type employee. So go ahead and choose this method, and we need to pass ID. Alright, let's say if employee object with given ID is not existing in database, then our REST API should throw a resource not found exception, right? For that, we're going to use or else through method, and this method internally takes supplier as a function argument, and we need to provide a lambda expression implementation for this supplier interface. Alright, so go ahead and call this method and just throw the exception, and so we are going to provide lambda expression, right? So here's the syntax. We're going to create an object of the resource not found exception, and this method will simply throw this exception object. So let me break this sentence, and let's give a custom error message, something like employee not exist with ID, and just pass the ID. Okay, perfect. Now we retrieved employee object from the database. Okay, and here in the method argument we have one more employee object, right? And this employee object contains all the updated information. Now we need to set all the information from this object to update employee object. For that, what we're going to do is we're going to simply call get setter methods to set first name, last name, and email. Here we're going to use update employee dot set post name. Let's get first name from the employee details object. Similarly, last name. Okay, update employee dot set last name, and get last name from employee details. Similarly, get email from employee details and set to update employee object. Employee details dot get email ID. Alright, it means that user can update employee first name, last name, and email. Okay, now update employee contains all the updated information. Now we want to save this employee object in database. For that, again we need to use employee repository, and let's call it save method to save this object. Now once we save updated employee object to the database, we're going to simply return the updated information to the client. Alright, again we're going to use response entity dot OK method, and then we're going to pass update employee object in a body. That's it. Pretty simple, isn't it? So what we have done, we have retrieved employee object from the database, and we have set all the updated information to update employee object, and we have saved that employee object to the database, and we have simply returned the updated employee object to the client. Now we have created a method. Now let's make this method REST API by using annotation. So let's go ahead and let's use add put mapping annotation. So whenever you have requirement to update the resource, then you have to use add put mapping annotation. Okay, just try to understand the difference between post and put. So post is used for creating a resource, put is used for updating the resource. Well, now we need to pass the method argument, that is id. So we can pass id as a path variable in a URL, and we need to bind the value of this id in the method argument. For that, we're going to use add path variable annotation. We have a second argument, that is employee details. Well, we have one more annotation, that is request body annotation. So this add request body annotation internally convert JSON into this employee details object. Alright, so this completes our update employee REST API implementation. Now let's go ahead and let's start Spring Boot application, and let us test this update employee REST API using Postman REST client. So let me go ahead and let me restart the server. So our Spring Boot application is up and running. Now let's go ahead and let's test this REST API using Postman REST client. So let's head over to Postman REST client and create a new request to test this REST API, and make sure that you choose put HTTP method over here, and here just type HTTP localhost 8080 /API /v1/employees. Okay, and we are going to update employee with id 1. So I'm going to pass one id in a URL itself. Okay, and go to body, and in a body we need to pass the employee information. Okay, and here I choose content type JSON, and in a body we just need to update employee first name, last name, and email. Okay, so let me go to get request here, and here I will just pass 1 to get a employee object with id 1 to just check employee first name, last name, and email. So you can see here employee first name Ramesh, last name Padatare, email id ramesh@gmail.com. Okay, so notice here the id 1. Now we want to update this employee first name, last name, email id. Okay, right now we have Ramesh Padatare ramesh@gmail.com. So let's go ahead and let's use this put request to update this information. So let me simply update first name from Ramesh to Ram, from Padatare to Jadhav, and email id ram@gmail.com. Okay, so go ahead and hit send button, and there we go. The employee id with 1 is successfully updated. Okay, what are the fields updated? First name, last name, and email id. Okay, and if you can make a get request to get an employee with id 1, you will get updated information. For example, let me hit a send button here, and there we go. First name, last name, email id is successfully updated for the employee 1. It means that our update employee REST API is working as expected. Let's go and let's build delete employee REST API. Let's head over to employee controller. Within an employee controller, let me quickly write the comment over here, build delete employee REST API. Let's write public, and let's use response entity as a return type, and this is generic class, so let's pass HTTP status as a type. Let's give method name as delete employee, and just pass the method argument id. Alright, now we want to check whether a employee record is exist in a database with this given id or not. For that, let me declare employee object here, and let's call employee repository, and then find by id method, just pass the id. Alright, and just call or else throw method. Well, or else throw method internally uses supplier functional interface, so we're gonna use lambda expression to implement supplier interface. So go ahead and use lambda expression now, new, and then just create object of resource not found exception, and just pass a custom error message over here, employee not exist with id, and just pass the id as argument. Perfect. Now we have just added a condition just to check whether employee is exist with a given ID or not. If employee does not exist, then this will throw a resource not found exception. Well, now go ahead and use employee repository dot. It provides the delete and delete by ID method. So now we have employee object, so we can call delete method, and we can pass an employee object to this delete method, so that this delete method will delete a record from the database. And look at here the return type. It doesn't return anything. Okay, why it is a return type? So go ahead and choose this method and just pass the employee object to it. So this will delete a employee record from the database. Alright, now go ahead and just return status code new and then response entity, and here in a body we pass http status dot no content. Alright, so we're not returning anything to client, hence we're just passing http status as no content. Alright, now we have created a method, that is delete employee method. Let's make this method as a REST API by adding annotation. So let's go ahead and let's use add delete mapping annotation, and we need to pass ID as a template variable, and we need to bind the value of this ID to method argument. For that, let's go ahead and let's use add path variable annotation. Okay, now we have completed delete employee REST API. Let's go ahead and let's test this REST API using Postman client. Let me start the Spring Boot application. Alright, our Spring Boot application is up and running. Let's head over to Postman REST client and let's create a new request to test this REST API. And here make sure that you choose delete HTTP method over here, and we're gonna use the URL http localhost 8080 API/v1/employees, and we need to pass the ID in the URL. For example, here I am passing ID 1 to delete a employee with ID 1. Okay, so go ahead and click on send, and there we go. We got a status code 204. It means that a employee with ID 1 is deleted successfully. In order to verify this, we can make a get employee by ID REST API call. So I am going to hit a send button, and there we go, not found. It means that employee 1 is not exist in database because we have just deleted it, right? Let me delete one more employee. Let me pass 2 and hit send button, and there we go. We got a status code 204, and let me verify it by using get employee by ID REST API. So this is the get, so I'm going to pass ID 2 and hit send button. There we go, not found. Okay, it means that our delete employee REST API is working as expected.